All right, here we are on Lesson 8 of Unit 5 in your Algebra 1 curriculum. This is on page 336 of your student workbook, and this is in Illustrative Mathematics by Imagine Learning. We're doing Lesson 8 exponential situations as functions. And so before we started class today, we did do a quick review where we're exploring exponential functions, but we wanted to do a quick review of what this word functions means again. And so students shared out that they recalled that the definition of function was for every input, there's only one output. For every x, there is only one y. We reminded ourselves that there was a vertical line test. If touches once, yes, a function. If touches more than once, it's not a function. So these were all the things that we recalled about what is a function. And then when we go into this warm-up discussing the rainfall in Las Vegas, we were thinking about this fact: is the accumulated amount of rainfall a function of time? And so looking at where these axes fall, is the rainfall a function of time? Like, does the rainfall that's measured depend on time? And so a sample answer from class is yes, it does depend on time. It is a function of time. So we would say rainfall, or let's say it exactly as it says, rainfall in inches is a function of time. And then to go further, for each number of days, like the d-axis, there is a specific or certain amount of rainfall. So we're taking that definition we were familiar from first semester. For every x, there's only one y, and we're putting it into context. For each number of days, the x-axis, there's a specific amount of rainfall. Okay, what if we look at it in the backward situation, the reverse situation? Is time a function of rainfall? Based on how much rain, can I tell what time it is? Does time depend on the rainfall? And we said no, the other way around does not work. So a sample answer would be there was no there was the same amount of rainfall for multiple different days. So it doesn't apply to say for every x there's only one y. There's now for every input there's multiple outputs, and so therefore it fails this concept of a function. So we said yes, the first way was a function. The second way did not work, so it doesn't always work to reverse those inputs and outputs. Next, in section 8.2, moldy bread, we noticed that we're starting with 1 square millimeter of mold, and then we left the bread alone to see what happened. We're seeing this pattern that it's doubling again every day after that. And so if the doubling pattern continues, how many millimeters will there be? So if we picture that there's 1, and then it's doubling day 1, day 2, day 3, day 4, 4 days, we got that there would be 16 square millimeters on that day. Now we're going to represent this relationship between this area with a table, an equation, and a graph. Those are the 3 representations we should always be really familiar and able to create. So creating our quick table, we're going to be doing, let's make that connect. Why is this not grabbing? Let's just do it with the regular drawer. Okay, so right here on this axis, we've got the number of days, D, and down here we have the area of the mold. And so we're starting with time 0, 1, 2, 3, 4, and it wants us to go out to 5 days later. We started with 1 square millimeter, and now we're doubling. So times 2 with every step repeatedly. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2, is 8, 8 times 2 is 16, 16 times 2 is 32. Let's write an equation for that pattern that we're seeing, part B. The area is equal to 1 millimeter times 2 repeatedly to the power of the number of days. And then to create a graph for this scenario, we were saying, okay, we need to get up to 32 on this axis. So we went by 4, 8, 12, 16, 20, 24. Okay, I need even more space here. Hang on. 4, 8, 12, 16, 20, 24, 28, 32. And then on the bottom, we can just go 1, 2, okay. So starting with the first dot at 0, 1, I'm taking it from the table above. 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32. And then I asked the class, do you think this should be connected or not? Is this a discrete or a continuous graph? And I had some students argue it should be discrete. Some students argued it should be continuous. So as long as whichever one you chose, you were able to support with an explanation, there were 2 scenarios, discrete or continuous could have worked. Discrete dots, not connected, or continuous could work as long as you support it. So if you said continuous, you're saying that there is time in between where we're measuring mold. If you said discrete, we're talking about just measuring once at the end of each day to see how much mold there is, and both those scenarios could work. Finally, is this a function or not? We said yes, blank, we're filling this little thing in here, is a function of blank. So notice we've got days and area. And so students said area is a function of time in days because days are the independent variable and area is the dependent. Area is dependent on time. I have to know how much time to see how much area there is. So yes, it is a function because area is a function of time. So we're going to go do that same sentence frame on these next ones. Blank is a function of blank. And so reading each scenario, in a biology lab, a population of 50 bacteria reproduce by splitting every hour on the hour. They split into 2. So we're talking about time again in hours, and we're talking about population. So I asked students, is population a function of time or is time a function of population? And they said yes. Population of bacteria is a function of time. The more time that passes, population is affected. Okay. Next, every year a new car is purchased, it loses value. Let's say that the new car, so we're talking again about time and years and the value of the car. So I asked students, is value a function of time or is time a function of value? And they said, yes, value of the car is a function of time. The more time that passes, the lower the value is of the car. It is dependent on that. And finally, we're talking about the algae bloom where scientists were looking at products, the area. Again, we're talking about area and time measured in days. And so asking the students, what do you think? Is area a function of time or is time a function of area? And they said, yes, area is a function of time. Some students were like, okay, so is time always an independent variable? And I said, it is a lot of the samples that we're going to look at, but don't worry, there is probably a scenario we could come up with where it is the dependent. But anyways, in all these cases, it did happen to work out like that. Finally, we looked at a scenario where we made a guesstimate on this equation and said, do we think this window would be a good window for graphing this on a graphing calculator or on an online calculator? Well, this is a function that begins at 20 and is going down to 0.8 of its remaining value with each step. So picture that I've got an axis that goes from negative 10 to 100, and then I've got an axis that goes from negative 100 to 1,000. But this function only starts at 20, way down here, and it's going down in value. So we're kind of like, 100, negative 100 to 1,000. That's kind of big of an axis. So do we think that this is going to be good? Students were saying yes or no based on just guessing first. And then we went to verify it by graphing. And when we graphed this on our online calculator, we saw that this was like a really far out zoom. And so, no, we did not like the way it looked on there. And so once we graphed that, we saw it was too zoomed out. We said, how could we adjust this? And students were saying, okay, maybe we just only need to go up to like 30 right here and like negative 10. Like we just need a closer window. And so again, that's the H variable, which is our X axis. Maybe we just go from negative 10 to 30. Sorry, that's our M variable. Let's change that back. So instead of going up to 1,000, let's just go up to 30. And then what about left to right? Again, maybe we just go from negative 10 to, I don't know. We just looked at different scenarios. Keeping it as 100 was a little bit too much. So maybe we just adjust it down a little bit to 50 or 20, etc. So we just talked about zooming in on both axes in order to get a better view of this function. And that's it. Moving on to your homework, the practice.